Okay, in this video what I'm going to do is introduce you and hopefully get mostly through one of the best simulations that I've seen. This is at the PHET Colorado site, and it is the Circuit Construction Kit DC only virtual lab. So if you want to try that out and you don't have the PowerPoint, which would be strange because this is on the PowerPoint, but let's just say you don't, this is where you get to go. Now there's another version which gives you more of the schematic diagram option under visual, and it gives you a couple of other options, but I just went with the virtual lab to make it a little bit more realistic. So here you have a battery, and you can do things like rotate it around by grabbing one of the circles at either side of it. You see how that goes, and then we can take a wire and attach that. If you want it to be longer or shorter, once you get it set, you can do what you like. And I'm just going to make this a very simple circuit. I'm going to grab in a resistor. Actually, I can make it even simpler. There we go. Now one of the things that you can't do is change the length of the resistors. So I can change the length of the wires, but I can't change the length of the resistors. And the first thing that you'll notice here is that once I get it all connected together, make a complete circuit, we now have charge flowing. And that's about it. That's all that there is to this in terms of just that happening. Now I could save this, or I could load it up if I've done something. You can install this on your computer, by the way, which might not be a terrible idea. Now one of the things that we can do here too is, we talked in the last unit about resistivity of wires. By default, it gives us zero resistivity. If I increase the resistivity, it should change the way that the electrons are moving, but it doesn't seem to be. We can also hide the electrons. So if you just like to look at the circuits itself and you don't like to look at the moving electrons, then we're fine there. Now this by itself is not that phenomenal. We've just drawn this thing out. So what I'm going to do is I'm going to try something a little bit different. There's a lot of different features that we can add. First of all, there's the one thing that we haven't used here is a light bulb and a switch. A light bulb and a switch, I can just remove that. I can stick in a light bulb instead. Now, the light bulb's a little tricky. It has one connection at the bottom and one connection at the side. If you look at a light bulb, this is actually how it works. A wire comes up through the bottom, and then that becomes a filament, and then it connects to the side of the light bulb, and there's an insulator in between. So we can do that. We can also change where the connectors are so it's a little bit more user-friendly, and you can change the resistance of this light bulb. So right now it says it's 10 ohms. Let's up that to, actually let's go 60 ohms. Okay, and when we do 60 ohms, it should change things a little bit. If I go, oops, I did not like that. Let's go 5 ohms. And you can see it's much brighter now, which meshes with what we would expect. Less resistance in the light bulb means that we're going to get the charges to move faster through it. What I'm going to do is I'm going to kind of restart, and I'm going to put in the battery first because we can't do a whole lot without the battery. I'm going to put in a wire here, and now what I'm going to do is I'm going to add a switch. Okay, now the switch works by opening and closing the switch. Right now it's open, and I'm just going to attach a resistor here, and we'll put the wire there. And so nothing's happening. Now if I close the switch, now we get stuff happening. Now I can change this resistance if I want to. Let's drop that to 5. Okay, notice that the colors have changed on the resistor. So if I go 20, we get these changes in colors happening. That's because those bands actually have something to do with the resistance, and so we'll talk about that a little bit later. Now if I select an actual wire, now you see there is an effect. So earlier when I was trying to play with the resistance, I didn't have a wire selected, so it wasn't doing anything. Alright, I can also change the voltage here. So I can change the voltage, I can change the internal resistance. It's by default set to 0. So I have all these different options. What I'm going to do is I'm going to show you now how to use a voltmeter and an ammeter to actually measure stuff. That'll be in the next video. I'll try to keep these a little bit short. So before I do that, I'm just going to show you the grab bag, and if you're not sure what a conductor is versus an insulator, this will help to teach you that information. One last thing, and it's kind of a word of warning. Let's say that I've got this done here and I want to just make this, let's say 0.5 ohms. It doesn't like this. Okay, it's basically said that you've just burned everything up. There's too little resistance, you're burning up the wire. Very, very bad news. And if this was a real experiment, you might have blown out the battery, or you might have burned out the resistor, or the wire might be burning to the point where it's melted in half, and then current will no longer flow. So it's kind of like a self-correcting situation, but it's self-correcting in a very negative way because you've just destroyed your lab equipment.